Hello guys, sa ating last topic for these midterms. So, video lecture na lang tayo para this week mag-focus na lang kayo sa mga reviews nyo for quizzes or pwede rin naman kayong mag-advance read for exam. Okay? So, we have lesson 10, Oscillation. So, for our learning objectives, we are to define and understand oscillation, learn about the concepts of oscillation such as period, frequency, and amplitude, and understand simple harmonic motion, and solve problems involving them. So first, we have oscillation. So oscillatory motion is a movement that repeats itself. Oscillation is a back and forth motion about an equilibrium position, wherein location where net force zero acting on the system is zero. So we have example of an oscillatory motion, pendulum. So we have the graph of a vibratory motion. So one complete cycle is from A to B. Ito siya, A, and then mag-flow siya dito to B, or C to D, or E to F. Okay? And the time taken for one cycle is called the period. So we have period. The period of a cyclic system, or vibrating or rotating, is the time required for the system to complete one full cycle. In the case of vibration, it is the total time for the combined back and forth motion of the system. Period is simply the number of seconds per cycle. So we have frequency F. It is the number of vibrations made per unit time or the number of cycles per second. So reciprocal lang siya ng period. So we have F is equal to 1 over T, wherein frequency is in hertz and then period I seconds. So hertz or Hz is equal to 1 cycle per second. And then displacement, pwede siyang maging x or variable y. It is the distance of the vibrating object from its equilibrium position. And the maximum displacement is called the amplitude. So dito sa example, ito, from this line, tumaas siya ng ganon. Yun yung tinatawag nating amplitude, the maximum displacement. So, kapag any na dito, yun yung tinatawag lang na displacement. Okay? So, we have restoring force. It is one that opposes the displacement of the system. It is necessary if vibration is to occur. It is always directed to push or pull the system back to its equilibrium position. And then we have simple harmonic motion, or SHM. It is the vibratory motion which a system that obeys Hooke's law undergoes. So, for example, yung graph kanina, it is an example of simple harmonic motion. So because of the resemblance of its graph to a sine or cosine curve, SHM is frequently called as sinusoidal motion. SHM oscillates at a single constant frequency, kaya siya tinawag na simple. And then we have Hookean system. It is one that returns to its original configuration after being distorted and then released. When a system is stretched a distance x, or kapag compression siya, negative x. the restoring force by the spring is given by Hooke's law. So, for Hooke's law natin, meron tayong formula F is equal to negative kx, wherein ang force ay yung F, naka-newtons. And then, yung K natin ay ang spring constant, naka-newton per meter. And then, yung X is yung stretch distance, and naka-meter. So, the negative sign indicates that the restoring force is always opposite to the displacement. It is sometimes useful to express Hooke's law in terms of F sub ext, or the external force needed to stretch the spring at a given amount x. This force is the opposite of the restoring force. So, meron tayong F ext is equal to kx. Natanggal lang yung negative kasi ito yung opposite na force ng restoring force. Okay? So, we're in force pa rin yung F sub ext, K is spring constant pa rin, and X is the stretch distance. So, we have the energy interchange. KE plus PE is equal to constant. Kaya meron tayong formula na 1/2 mv squared plus 1/2 kx squared is equal to 1/2 kxo squared. Yung x sub o, yan yung amplitude. Okay? And then, same na dun sa mga other variables kanina. And then, ito yung v, yun pala yung speed natin. Okay? So, speed is in SHM. Galing sa formula kanina, kapag ide-derive mo yung v, makukuha tong formula. Okay? Then, same variables pa rin. M is for mass, K is for spring constant, and X is for the stretch distance, and X sub O is for amplitude. And then, acceleration naman, equating the two equations ng forces, F is equal to F. Yung F natin, from Newton's law, F is equal to ma, and F is equal to negative kx from Hooke's law. Makukuha natin yung formula for the acceleration, negative kx all over m. Yan, m is for mass, k is for spring constant, and x is the stretch distance. Okay, so ito naman sa reference circle natin, makukuha tong formula na negative v sub o sin theta. Okay, ito yan. V sub o sin theta. Kasi opposite nitong theta is si Vx. When Vx is positive, it points in the positive x direction. Otherwise, it points in the negative direction. For this one, nakapoint siya sa negative. Kaya siya may negative sign. And then, ito yung mga kailangan yung formula na galing sa reference circle. Okay? Take note nyo na lang to. Then, we have period in SHM. The period T of SHM is the time taken for point P to go around the reference circle. So, galing to sa reference circle. Ito yung formula natin. And then, for Hookean spring system naman, we have T is equal to 2 pi square root of m over k. So, m is for mass, k is for spring constant, x is the stretch distance, x sub o, amplitude, v sub o is the maximum speed. Ayan. Kapag, pansin nyo guys, kapag may mga sub o, yun yung mga max natin, okay? So, for example, dito sa x sub odd, amplitude, di ba yan yung tinatawag nating maximum displacement. So, dito din sa speed, maximum din, kaya naka-sub O siya. Okay? So, we have acceleration in terms of period. Ayan yung formula natin. Okay? And then, same pa rin. Okay? Dapat small letter A to. Okay? Letter A dapat to. Acceleration. Then T. For pendulum naman, the simple pendulum undergoes SHM if its angle of swing is not too large. So, ganyan. Kasi bakit ganon? Diba ang pendulum, ganito siya. Ay, sorry. This straight. Mahirap kasi magsulat guys pag naka-mouse. So, ganyan. Pendulum, diba ganun yan? Or back and forth lang yan. So, may angle kasi tayo dito. Kung too large na yan, pwede pa yan. Babalik pa yan. Pero what if kapag nandito na siya? Tapos lumagpas pa dun. Di hindi na magbaback and forth yan. Parang magiging circular motion na siya. Okay? So, kailangan yung angle nyo for pendulum not too large. Okay? So, where T is the period, L is for length, and G is gravitational acceleration. So, first example natin, for the motion shown in the figure, what are the amplitude, period, and the frequency? So, mag-analyze lang tayo ng figure, So, solution natin, recall that amplitude is the maximum displacement from the equilibrium position. So, dito, equilibrium position natin, itong 0. Okay? Ano ba yung maximum? Di ba tumaas siya ng ganun? Ito na yung top niya. So, we have 0.75. Okay? 0.75. Teka, correction lang, dapat cm to. Okay? Cm dapat to. Kasi cm tong nakalagay dito sa graph natin. Edit ko na lang guys. And then next one, period is the time for one complete cycle. So, take nyo yung cycle from A to B. Ano ba yung time kay B? Diba 0.60. Kay A naman, 0.40 seconds. O di, subtract mo lang yun. So, we have 0.6 minus 0.4. Answer is 0.2 seconds. The next one is the frequency, which is reciprocal lang ni period. Di, substitute mo lang, kukuha mo si 5 Hz. Okay? So, next example, a spring makes 12 vibrations in 40 seconds. Find the period and frequency of the vibration. So, first one, meron tayong period. Elapsed time over vibrations made. Dapat to. Vibrations made. Okay? Vibrations made. Dapat. Diba? Recall natin na sa definition ng period, how many seconds per cycle siya. So, ang seconds niya is yung elapsed time or 40 seconds. And nakailang cycle siya. For this case, we have 12 vibrations. Kaya meron tayong T is equal to 3.33 seconds. And then for frequency, reciprocal lang ni period ulit. Makukuha nyo 0.3 Hz. Okay, next one tayo. When a 400 gram mass is hung at the end of a vertical spring, the spring stretches 35 centimeters. What is the spring constant of the spring, and how much further will it stretch if an additional 400 grams mass is hung from it? Solution natin is, meron tayong force ext is equal to ky. Okay? Ang hinahanap kasi is the spring constant. So, ang given is mass. So, ano ba yung force? Diba? Mass times gravity lang yan. So, maging mg is equal to ky. So, dito, given 400 grams divided by 1,000, kaya naging 0.4 kilograms times 9.81 meter per second square. And then, newtons na yan na. And for the displacement, meron tayong 35 centimeters. Bakit pala y yan? Yung formula natin kx. Kasi yung given system natin, vertical. Okay, so may vertical spring daw dyan. Then, may naghang na 400 grams. Kaya, vertical. Okay? Kaya naka-y siya. Ganun lang yan, guys. So, 0.35 meters. So, kapag ikakalki nyo, makukuha 11.21 newtons per meter. And then, for additional load na 400 grams, i-plus nyo lang yung grams. Okay? So, given na 0.4 kilograms, plus may additional ulit na 400, times 9.81, and then i-multiply nyo yung spring constant na nakuha natin, makukuha ay 0.75. Or pwede mo rin namang gawing solution na since sa 400 grams, nag-stretch siya ng 35. O ilan ba yung nadagdag? 400 ulit. O di times 2 mo lang yung 35 cm, makukuha mo na yung 0.70. Okay, so pwede rin 2 times 35 cm or 0.35 meters. So, makukuha mo 0. Oops. Sorry guys. Mahirap talaga ng naka-mouse. 0.70 meters. O, same lang lalabas dyan. Okay, so proceed tayo. So we have example number 4. A 50-gram mass vibrates in SHM, simple harmonic motion, at the end of a spring. The amplitude is 12 centimeters and the period is 1.7 seconds. Find the frequency, spring constant, maximum speed, maximum acceleration, and the speed when the displacement is 6 centimeters and the acceleration when displacement is 6 centimeters. So first, pinapahanap is si frequency. Frequency is 1/t lang, okay? May given tayo na period, 1.7, so direct substitution lang yan. Makukuha ay 0.588 Hz. So, yan na yung answer natin for letter A. Letter B naman, pinapahanap si spring constant. So, since given natin ay yung period, ito, meron tayong formula na 2 pi square root of m/k. So, substitute natin 1.7 seconds and then mass na given 50 grams. Okay, kaya 50 divided by 1,000, 0.05 kilograms na. Then, calculate nyo yan, K is equal to 0.683. Okay? Kung ayaw nyo nang nag-shift solve, ganito yan. So, 1.7 divided by 2 pi. And then, para maalis yung square root, o di squared nyo. Squared. So, matitira 0.05 over k. And then, cross multiply, k is equal to 0.05 divided by yung 1.7 divided by 2 pi squared. O, ganyan yan. For the next one, maximum speed of the mass. Meron tayong formula na V sub O is equal to X sub O square root of K over M. Okay, tandaan na yung V sub O, yun yung maximum speed. Ang X sub O naman is the amplitude. So, substitute nyo si 0.12 meters, given natin is 12 cm. Okay, divided by 100, 0.12 meters. And then, isubstitute nyo yung K na nakuha, 0.683. And then, given mass na 0.05. So, makukuha nyong answer is 0.4435 meter per second. Next one. Maximum acceleration naman tayo. So, we have formula A sub O is equal to K times X sub O divided by M. So, substitute nyo lang yung K, nakuha nating value kanina. Then, yung 0.12 ulit itong amplitude na 12 centimeters. And then, mass, given din yan. Calculate nyo, makukuha ay 1.64 meter per second squared. How about speed when x is equal to 6 cm? So, ito yung formula natin. Meron tayong given amplitude, given displacement na 6 cm, and then k over m. Substitute nyo lang yan, lahat ng values, makukuha nyo si 0.384 meter per second. Last one, we have acceleration when x is equal to 6 cm. So, yan yung formula, 0.683 times 0.06 kasi 6 cm divided by 100, makukuha nyo 0.06 meters. Okay, tapos itong 0.05, given mass yan na 50 grams. Makukuha nyo negative 0.8196 meter per second squared. And then, sample number 5, compute the acceleration due to gravity at a place where a simple pendulum 150.3 centimeters long makes 100 cycles in 246.7 seconds. So, meron tayong solution na t is equal to, tandaan na yung period ay seconds per cycle. So, meron tayong 246.7 seconds and then nakagawa siya ng 100 cycles. So, divide mo lang yun. Kukuha mo si 2.467 seconds. And then, meron tayong formula na t is equal to 2 pi square root of L over G. So, substitute mo yung nakuhang period. And then, meron tayong given na length, 150.3 centimeters long. And then, gravity. So, makukuha natin ay 9.749 meter per second square. Okay? Yung 150.3 cm, kinonvert lang ng meters. Okay? Kaya siya naging 1.502. So, matitirang mga mga tawag dito, units IC, seconds, and then meters. Kaya naging meter per second squared. that ends our presentation. Again, this will be the last topic for midterms exam. So, mag-aral kayong mabuti and God bless sa exam. Bye guys!